is Dr. V. Anitha Rani, Professor, Department of Chemistry from Institute of Aeronautical Engineering. And we are going to discuss about fuels. So in fuels, we are going to discuss about classification of fuels, classification of the fuels. And in classification of the fuels, we are going to discuss about solid fuels, liquid fuels and gaseous fuels. So in solid fuels, we are going to discuss about analysis of coal. There are two types in analysis of coal: proximate analysis of coal and ultimate analysis of coal. So first of all, what is a fuel? What is a fuel? So fuel means it is a combustible substance. Fuel is a combustible substance which on proper burning produces large amount of heat. Fuel is a combustible substance. Fuel, it is a combustible substance, produces a large amount of heat on burning. So fuel, we can take solid fuel or liquid fuel or gaseous fuel. Fuel containing carbon as main constant. Carbon as a main constant. It is a combustible substance. So when we are burning a fuel, containing carbon, so we get the product, the combustion products, CO2. The combustion products, CO2. If a fuel is containing hydrogen, so we get the combustion products, H2. So fuel is a combustible substance which on proper burning produces a large amount of heat along with the combustion products. The combustion products are CO2 and H2. So we are going to use more fuels nowadays because of the increasing population. So what is the definition of fuel? Fuel is a combustible substance containing carbon as the major constant which is capable of releasing large amount of heat that can be used for domestic and industrial needs. So these fuels we are using for domestic purpose and industrial purpose. So during the process of combustion of the fuels, the atoms of carbon and hydrogen that combine with oxygen with a simultaneous liberation of the heat. So we can see in this reaction, in this equation, we can see that fuel plus O2 gives rise to combustion products plus heat. So a fuel, it is a combustible substance which on proper burning produces large amount of heat energy. Okay. For example, we can take the coal that is used in locomotives, in industries as a reducing agent in blast furnace. So petrol, another fuel example is petrol that is used in internal combustion engines. So we will use the coal in industries. For example, in iron industry. If we take another example, petrol, we will use in internal combustion engines in the vehicles. So a fuel is any material that can be made to react with other substance so that it releases energy as heat energy or to be used for the work. So the combustion is the process of oxidation. So that is nothing but loss of the electrons. So that provides a heat energy. So every combustion is an oxidation, but every oxidation is not combustion. So combustion, it is oxidation reaction. Oxidation of the fuels takes place in the presence of oxygen. For example, so we will burn the wood, combustion of wood. So we will burn the petrol, combustion of petrol and kerosene. It gives heat energy. And wood is one of the first fuels used by the human beings. So in this diagram, we can observe here, we can see we are burning the wood. The heat is liberated. So when we are burning the fuels in the presence of O2, in the presence of oxygen, heat will be liberated. So fuel plus O2, that gives rise to products of combustion plus energy. So in this diagram also we can observe very clearly that is fuel plus oxygen Okay, when we are going for combustion, that is burning of the fuels, we can see the combustion products CO2 and water. So we can look into the diagram. CO2, that is one of the combustion product, and water, that is one of the combustion product. So along with the power is produced, the heat is produced. So in this diagram, we can observe clearly here what we are taking the examples like crude oil, and we are taking the CNG gas, and we are taking the wood. All these are different kind of fuels. So when we are using these fuels, when we are burning these fuels, producing large amount of heat along with the combustion products. So classification of the fuels. So classification of the fuels that is divided based on the occurrence, based on the physical state of aggregation. So first one is based on occurrence, means how the fuels are available in nature. The fuels are available in nature. So and the fuels are available like man-made, means artificial fuels will be there. Okay, so based on occurrence, there will be two types of fuels, natural and artificial fuels. Natural, so these are also called primary fuels, or artificial fuels, these are called secondary fuels. Based on occurrence, occurrence means how it is available to us, how it is available to us. So fuels are available to us, means from the nature, that are called natural fuels. So we are preparing, the human beings are preparing, so that is called artificial fuels, or it is called secondary fuels. And based on the physical state of aggregation, means nothing but physical appearance. So we will see, okay, how the fuels, that is physical appearance, either they are in solid shape, or they will be in liquid shape, or they will be in gaseous. Okay, so physical state of the fuel, physical appearance of the fuel. So there will be divided into three types: solid fuels, liquid fuels, and gaseous fuels. So natural fuels, so they will be divided based on physical state of aggregation into solid fuels, liquid fuels, and gaseous fuels. And artificial fuels also, so they will divided into three types based on physical state of aggregation, physical appearance, solid fuels, liquid fuels, gaseous fuels. So we can see what are the examples of natural fuels. We can take wood, coal, petroleum, natural gas. Wood, coal, natural gas, and petroleum. So these are natural fuels. And artificial fuels are, we can take kerosene, petrol, diesel, this LPG, CNG, all these are secondary fuels. So natural fuels, here we can see in the diagram, the solid fuels are wood, peat, lignite, bituminous coal, anthracite coal. And secondary fuel, we can see the example charcoal and coke. So natural fuels, again there are three types: solid, liquid, gaseous. Solid fuels, so that is example we are taking, natural solid fuel is coal, natural solid fuel is coal, and artificial solid fuel is charcoal, coke. And here next we can take the example the natural liquid fuel or primary fuel, so that is crude oil, or it is called petroleum. And artificial or secondary fuels, we can take the example petrol, diesel, kerosene, that is artificial or secondary fuels, liquid fuels. So in this diagram, we can say that is a natural or primary fuels which are in the form of gaseous state. Gas. Example, natural gas. So artificial or secondary fuels, that is we can take the example coal gas, oil gas, biogas, water gas. So we can see in the diagram. So the natural gas, that composition we can see methane, ethane, propane, butane. So this is the composition of natural gas. So what is the major constant present in the natural gas is like a 94% or 90%. So that is the methane in natural gas. So when we are burning the coal, so we can collect the coal gas. That is the secondary fuel, secondary gaseous fuel. So when we are burning the coal, so what we can collect? We can collect the coal gas. So that is the secondary gaseous fuel. So we can see here the classification of the fuels are two types, primary and secondary fuels, or natural fuels or artificial fuels. So natural fuels, again three types, solid fuels, liquid fuels, gaseous fuels. Artificial fuels are three types, solid fuels, liquid fuels and gaseous fuels. So here we can see some more diagrams are there. Okay, we have given example: solid fuels, wood, coal, charcoal; liquid fuels, kerosene, petrol, diesel; and gaseous fuels, CNG, LPG, and biogas. All these are examples of the gaseous fuels. Now, so we are going to discuss now solid fuels. In solid fuels, we are going to discuss about analysis of coal. So we have to analyze the coal. It is very, very important. We have to analyze the coal. So why we have to analyze the coal means because when we take different areas, different countries, for example, our Indian coal, where we collect the coal from Singareni. So our Indian coal, it contains more ash content, more ash content. When you take other countries where the coal is available, so that coal maybe it is having less ash content. So we have to go for analysis of coal to determine the how much percentage of moisture, the percentage of volatile matter, and the percentage of ash content present in the given sample of the coal. So that if we know the quality of the coal, we can use that coal in industries. That coal we can use in industries, then we does not get any problem. And also, first of all, we have to know what is calorific value of the fuel. Calorific value of the fuel. Calorific value of the fuel. So what is calorific value of the fuel means? The total quantity of heat liberated when a unit mass of the fuel is burnt completely. For example, we are taking 1 gram of coal sample. We are burning that coal sample. How much heat is liberating? How much heat is liberating? And that much heat, how much heat is liberating, we will note down how much heat is liberating, and we can see that how much calorific value of that fuel is containing. Okay, so what is calorific value of fuel means? The total quantity of heat liberated when a unit mass of the fuel or unit volume of the fuel is burnt completely. That is known as calorific value of the fuel. Calorific value of the fuel. Now, for example, we'll take petrol and diesel. Okay, so which is having more calorific value, so which can produce more heat. For example, petrol is producing more heat compared to the diesel. So based on knowing the calorific value of the fuel, then we can choose and we can use it. So in that way, we have to go for analysis of coal so that we can select a better quality of coal and we can use that coal in industries and in iron industry or steel industry for heating purpose. So the analysis of coal, there are two types are there: proximate analysis and ultimate analysis. In proximate analysis, we are going to determine percentage of moisture, percentage of volatile substance, percentage of ash content, and percentage of fixed carbon. So this proximate analysis, it is also known as quantitative analysis. And next type is ultimate analysis. The ultimate analysis, it is also known as elemental analysis. We are going to determine in this analysis percentage of carbon, percentage of hydrogen, percentage of nitrogen, percentage of sulfur, and percentage of oxygen. So this is called elemental analysis. So it is also known as qualitative analysis. Of coal. So first we are going to discuss about proximate analysis. Percentage of moisture we are going to find out. So what we have to do is we have to take 1 gram coal sample in a crucible, in a silica crucible. See, this is the silica crucible. So we are taking a 1 gram coal sample. 1 gram coal sample in a crucible. And this crucible we are keeping in the oven. So this is the oven. And we'll maintain the temperature in the oven. We are going to maintain the temperature 105 to 110 degrees centigrade. 105 to 110 degrees centigrade for 1 hour. So we are going to heat the coal sample at 110 degrees centigrade for 1 hour. After completing 1 hour, we will take out the crucible. We will take out the crucible containing coal sample. We will cool it in a desiccator. We will cool it in a desiccator. So desiccator will be like a glass jar. So it will be like a glass jar. It is a glass jar. So where the space is available to keep the crucible, crucible with the coal sample. So we will keep some cooling stones will be there. Some cooling stones we can keep in the desiccator. So this is the desiccator. It is like a glass jar. We'll keep the coal sample in the desiccator and we will cool the coal sample. After cooling, we are going to take the weight of the coal sample. Then we can determine the percentage of moisture. So percentage of moisture is equal to loss in weight due to the removal of moisture by weight of coal sample taken into 100. So percentage of moisture is equal to loss in weight due to removal of moisture by weight of coal sample taken into 100. So we can determine here percentage of moisture in this process. So next percentage we can look into this diagram. Okay, so this is the silica crucible, coal sample. So we will take 1 gram coal sample. So we'll keep in the oven, maintain the temperature 110 degrees centigrade, and for 1 hour. So we'll cool it in a desiccator. This is the desiccator. So this is the desiccator. We'll keep crucible in the desiccator containing the coal sample. Then we can take the weight of the coal sample and then we can find out the percentage of moisture is equal to loss in weight due to the removal of moisture by weight of coal sample taken into 100. So next, volatile matter. So we'll take the crucible 1. So after determination of the percentage of moisture, the same crucible we will take and we will find out the volatile matter present in the coal sample. So we'll take the crucible 1 and we'll keep in the muffle furnace. We can see here muffle furnace. So we can see in the picture. Okay, we can keep in the muffle furnace that the crucible 1, the crucible with the containing coal sample, means in 1 gram of coal sample only. We are going to determine percentage of moisture, percentage of volatile matter, percentage of ash content, and percentage of fixed carbon. Means in 1 gram of coal sample only, we are going to find out all. Means percentage of moisture, percentage of volatile matter, percentage of ash content, percentage of fixed carbon. So in 1 gram of coal sample only, we are going to determine everything. So in determination of volatile matter, we are going to take the same crucible with the coal sample and we'll keep in the muffle furnace and we'll maintain the temperature 950 degrees centigrade for 7 minutes. Exactly 7 minutes. So the crucible is covered with a lid. And maintain the temperature 950 degrees centigrade for 7 minutes. After that, we will take out that crucible. We will cool it in a desiccator. After cooling, then we will take the weight of the coal sample. And we can find out now percentage of volatile matter is equal to weight of means loss in weight, how much weight we are getting, that we will take the weight. Loss in weight due to the removal of volatile matter by weight of coal taken into 100. For example, in percentage of moisture, when we are taking the weight of the coal sample, we got 1 gram we have taken coal sample. But when we have taken after doing the process percentage of moisture, we got 0.8 gram. Now after doing volatile matter, we got 0.6 gram. Means some loss in weight we can observe that, some 2 grams loss in weight. So we can write that weight, we can find out the percentage of volatile matter. So percentage of volatile matter is equal to weight of loss in weight due to the removal of volatile matter by weight of coal sample taken into 100. So the temperature we have to maintain in volatile matter is 950 degrees centigrade for 7 minutes. So in this diagram also we can see that how we are taking the crucible and we are heating in the oven and we are cooling in a desiccator. So next, ash content. So the same crucible too. So we completed volatile matter. So we have done the experiment, that is determination of volatile matter in coal sample. Now we will take crucible 2. So the same coal sample. Okay, after completing volatile matter, the same crucible with the coal sample we are going to take and we will determine the ash content. So we'll take the crucible 2 and we will keep in the muffle furnace. We'll keep in the muffle furnace and will maintain the temperature 700 degrees centigrade, or we can maintain 725 degrees centigrade. 725 degrees centigrade, and we have to maintain the time exactly half an hour. Exactly half an hour. So after completing half an hour, we will take out the crucible with the coal sample. We will cool it in a desiccator. Then we will take the weight. So we can find out percentage of ash is equal to weight of ash formed or weight of residue left in the crucible by weight of coal sample taken into 100. Weight of coal sample taken into 100. So in that way we can determine percentage of ash content. So percentage of fixed carbon. Percentage of fixed carbon. So how to find out percentage of fixed carbon? Percentage of fixed carbon is equal to 100 minus percentage of moisture plus percentage of volatile matter plus percentage of ash. So we know now percentage of moisture we know, percentage of volatile matter we know, percentage of ash. So we can find out easily percentage of fixed carbon, that is 100 minus percentage of moisture, percentage of volatile matter and percentage of ash. Now we have to know here the significance of proximate analysis, importance of proximate analysis. So when we are doing this process, by knowing the how much percentage of moisture we got, how much percentage of the volatile matter we got and ash content, based on that we can know the importance of proximate analysis. If a coal sample is having high moisture content, if we are burning that coal, so there will be loss of the heat in the form of evaporation. Loss of the heat in the form of evaporation. So there will be reducing or lowering the calorific value of the fuel. Lowering the calorific value of the fuel. So there should be always less percentage of moisture in coal sample. So that coal is called a good quality of coal. So lesser the percentage of moisture or better the quality of the coal. So volatile matter. In coal sample, so the volatile matter increases. How means due to the presence of combustible and non-combustible gases. So what are the combustible gases means? Methane, hydrogen. So that are combustible gases. What are non-combustible gases means? We can take CO2, N2. These are non-combustible gases. If these are present in the coal sample, then we can know that that coal sample is that is containing more volatile matter. So when this coal sample containing more volatile matter, when we are burning that coal, so it produces long flame, high smoke. It produces long flame and high smoke, and it reduces the calorific value of the coal. So lowering the calorific value of the coal, because the volatile matter, it will be escaping as unburnt coal. So it will be escaping, evaporates. It will be escaping as a unburnt coal. So reduces the calorific value of the coal. Calorific value of the coal means nothing but loss of the heat will be taking place. So volatile matter also influence the design of the furnace. So why means, so when we take the furnace and burning the coal, so what we are getting, if more volatile matter is present, we are getting a long flame that is hitting the wall of the furnace. That is hitting the wall of the furnace. So we are getting long flame and high smoke also. So volatile matter influence the it is influencing the design of the furnace. Design of the furnace. Since the higher volatile matter, so the larger is the combustion space required. So we need a large furnace. So we have to design in a different way. So large combustion space is required. So always there should be a lesser percentage of volatile matter should be there. Then we can see that that is the better quality of the coal. So lesser the percentage of the volatile matter, better the quality of coal. So ash content. So ash content, it reduces the calorific value of the coal, and this increases the cost of transportation and handling, storage and disposal. Because we are getting more ash content means always we have to dispose it. And storage, we have to store that ash, that is also difficult. Okay, we cannot handle it. We cannot handle it. And when we are burning the coal containing more ash content, we get a lumps of ash. We will get a lumps of ash. So this lumps of ash, it will avoid the flow of air, because we will use the air for burning of the coal. If the air supply is not taking place properly when we are burning the coal, see, it does not burn properly. Okay, so that here what happens means there will be loss of the heat will be taking place and reducing the calorific value of the coal. Reduces the calorific value of the coal. So always lesser percentage of the ash content, better the quality of the coal. Better the quality of the coal. So the ash content present in the coal will be due to the presence of silica, alumina, iron, magnesium and calcium. If these are present in the coal, so that indicates that there will be more ash content in the coal. So presence of silica, alumina, iron, magnesium, calcium. So ash is formed after burning of coal. It will be in the form of the oxides. In the form of the oxides like silica oxide, alumina oxide. So we should see that always there should be a less ash content. Then it will be the better quality of the coal. Then we do not get any problems when we are burning the coal sample. Next, fixed carbon. If the carbon percentage is more present in the coal, so we get more calorific value. More heat will be liberated. More heat will be produced. So always there will be the carbon percentage should be more in the coal. Higher the percentage of fixed carbon, better the quality of coal. Higher the percentage of fixed carbon, better the quality of coal. So higher the fixed carbon in coal, greater is its calorific value and better is the quality of the coal. So this is the importance of proximate analysis. So we understood that lesser the percentage of moisture content, better the quality of coal. Lesser the percentage of volatile matter, better the quality of coal. Lesser the percentage of ash content, better the quality of coal. But higher the percentage of fixed carbon, then better the quality of. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.